Okay, so let's look at the 5-1 practice handout. And I'm going to break this up into a few different videos. So one of the things is we had all these exponent rules, so I wrote them over here on the right side in that red box to help us work our way through some of these problems. So let's just kind of approach some of these. And there's usually more than one way of doing them too, but we'll definitely come up with at least one per part. So in number one, let me pick a different color pen here. Why don't we do the inside of the parentheses first? That's probably a good place to start. So the inside, it's 1/4 times 2 cubed, which is 8. 2 times 2 times 2, all squared. And then 1/4 times 8, well, that's really 8 divided by 4, so that's just 2 squared, which is going to be 4. And then we're done. So that one's pretty quick. In the next one, we could do a couple of things. One is we've got 11 to the 5th over 11 to the 7th. And notice if I have some number to the m divided by some number to the n, then it's that same number to the top minus the bottom exponent. So this becomes 11 to the 5 minus 7 to the negative 1. So that's going to be 11. I'll do these so that they look like ones. So that's going to be 11 to the negative 2 to the negative 1. And then that's this form right here now. So it's something to a power to another power. So that when that happens, you just multiply the powers. So that becomes 11 squared, which is 121. Another way of doing this one is to actually do the negative 1 part first. And we talked about in class that if you wanted to switch an outer exponent to a positive, that's the same thing as just flipping the fraction on the inside. So that becomes 11 to the 7th over 11 to the 5th, all to the positive 1, which is really just 11 to the 7th over 11 to the 5th, and then that becomes 11 to the 7 minus 5, which is 11 squared, which is 121. So you could do it that way too. Let's take a look at the next one here. So I'll go back to blue. So it's 3 squared cubed. Well, that's this form. So that's going to be 3 to the 2 times 3, which is 3 to the 6th. And then, let's see, if we type that in on a calculator, what do we get? Oh, my calculator won't turn on. File, close. Let's restart that. So 3 to the 6th, 729. Okay. The next one we have is negative 8. I'm going to put right here a little 1 for to the first times negative 8 to the third. Well, that's this form. Same base, different exponents, and then you can combine them so that it's negative 8, the same base, to the 1 plus 3. So that's going to become negative 8 to the 4th, which will turn into, and notice here, if I type in negative 8 all to the 4th, that's not actually what I wrote down here. It's going to give me a negative answer, negative 4096. What I want, though, is negative 8 all to the 4th, because you know if you raise a negative number to an even power, it should be positive. So 4096. There we go. Let me box this one too. And we'll box that one. Okay, let's take a look at the next one. So it's a fraction cubed. And when you have a fraction to a power, it's really the numerator to the power over the denominator to the same power. So that's going to come out to be 8 on top over 5 times 5 times 5, which is 125 on the bottom. And then that's as far as you can go. And then for part F, go back to red here. For part F, well, you can do this a couple ways. What I'll do is I'll split it into 2 fractions. Everything's multiplied together, top and bottom, so I'm allowed to kind of split this up like this. 4 over 8 times 10 squared over 10 to the negative third. Well, the 4 over 8, that's just 1/2. And then the 10 squared over 10 to the negative third, that looks like, well, actually, we could do this a couple ways. I'm going to take it this way. I'm going to leave the 10 squared by itself on top. The 10 to the negative third on the bottom, that becomes 10 to the positive third if I move it to the top. And then on the bottom, there's nothing left. So then on top, this is going to be 10 to the fifth over 2. And then that's going to be, well, 10 and then squared, cube, fourth, fifth over 2. So that comes out to be 50,000. That's 100,000 divided by 2. Okay. So I'll stop there, and then I'll cut number 2 into a couple parts too.